Hello class, sorry I couldn't be there today, but hopefully y'all are doing well. Mr. Banfield should be your sub, so hello Mr. Banfield. I want to teach you a quick 15-minute lesson about graphing based on information of increasing, decreasing, and concave up, concave down. What if I give you the information, would you know how the graph looks like? So if you take out your notes, this should be part of your packet, Chapter 3, Section G. And I'm going to just go over real quick for you the types of intervals that you could have. Here's one example where f prime is greater than 0. If f prime is greater than 0, that tells me that it's increasing. If f double prime is less than 0, that tells me it's concave down. So I need to draw an example of when my slope is increasing, but my concavity is down. So here's an example. So you see in this little line that I drew, it's increasing, but it's concave down. Here on this right one, I see f prime is less than 0, and f double prime is less than 0. That means it's decreasing and concave down. So if it's decreasing and concave down, it looks like this. And you can see it sort of looks like the second half of this one. As I scroll down, let's look at some more. What if I have f prime is less than 0, which means it's decreasing, and I have concave up, because it's greater than 0. That will look like this. See how my slope is decreasing and it's concave up? On the right side, you can probably guess how it's going to look like. It says f prime is greater than 0, so it's increasing. And it says here that f double prime is greater than 0, so it's concave up. And this is an example of that. Again, it looks like the finished portion of that one. This is an example where something is increasing and it's concave up. Now, can we do that if I give you all the information and I want to put on a graph? Alright, there you go. So moving on to the next page. Here's a graph and it says sketch the following graph if it has the indicated characteristics. The very first thing I'm going to do you see how at the top it has all these intervals? I have x is less than -4, I have -4 to 0, 0 to 2, 2 to 5, and greater than 5. I want to mark off these intervals on my graph by, and maybe I could decrease this real quick. What I'm going to do is I'm going to look at this table and fill in these intervals with dashed lines. So see how it says all those less than -4? So I'll make a dashed line, or maybe make it easier. Oh, no. I'll do a dashed line. I'll make a dashed line over at -4. And then next one says -4 to 0, so I'll have a dashed line at 0. I know it's not straight, but oh well. Then I have from 0 to 2, so that's a zone. So let me put a dot at 2. And then I have another zone from 2 to 5, and then 5, from 2 to 5, and 5 on, So again, if you are lost or don't know what I did, first thing I did is I looked at the intervals that the question gave me, and I put dashed lines at them. So -4, 0, 2, 5, I put dashed lines at those. Alright, now I'm going to look at what it looks like at these intervals. Okay. First of all, it says that -4 to 4, f of x is positive. Okay, so that means I'm above the x-axis. It says here that it's increasing and it's concave up. So it has to look like, oh, I'm also looking at this one here. It says -4, the value is 5. So at -4, the value is 5. So there's a dot right there. So it says that it's positive, it's increasing, and it's concave up. You can look back at your original notes that we took in the last page. But how do I draw something that's increasing and concave up? That's this one. It looks like this shape. So I'm going to draw. Oops. I'm going to draw like so. Alright, now moving on. This one says, my next point I have is 0 at 0. Or how about this, to make it easy for you, let's just go through all these points. Here I have 2, -3. So 2, -3, you might not be able to see this. Sorry, it's supposed to be 2, -3. And then I have 5, 0. So at 5, I'm going to have a point at 0. Okay, now I drew this one. Actually, it might be easier for you to see if I put this in a different color. So, oh, never mind. There you go. There, it's in blue. Alright, next one it says that my f prime is negative and my f double prime is negative. So it's decreasing and it's concave down. So it has to be decreasing and concave down, and it has to hit 0, 0. So this must look like So it's decreasing and it's concave down. Next one, I'm looking at this one, I have one that is decreasing and it's concave up. So if it's decreasing and concave up, it must look like, and again, if I connect these dots, you could sort of tell how it's going to look like. So you see how this is decreasing and it's also concave up. The next one, to get to 5, 0, you'll notice that I have positive, positive, which means it's increasing and concave up. Plus I have to get from this dot to this dot. So obviously I'm going to draw a shape that looks like, no, looks like that. So it's increasing, concave up. And the last one, it says on, you have a positive for f prime, which means it's increasing, and a minus, so it's increasing and concave down, which means it has to look like that. Well, these are connected, but so there's the picture of my graph based on a table, how it would look like. You should feel comfortable. You can look at your notes. When given a table, know how to graph it. Okay. On to the next example. This one says, analyze and sketch the graph of the function. Use and label relative extrema, points of inflection, asymptotes, and limits at infinity. So what I'm going to do is I'm going to do all the steps that we've been doing to get me a graph. Okay. So first, let's do, to get relative extrema, let me do my critical numbers. So to do my critical numbers, let me take the derivative. You guys can all take the derivative. What's the derivative of this one? Yeah, it's going to be 5x to the fourth. I'll just put 5x to the fourth like that. And it's going to be minus 4x squared. Okay, so far? And then so I'm going to take the derivative. I'm going to set it equal to, 0. I will then do what? I'm going to factor it. So it's going to be x squared is in the factor of both of them. I'll get 5x squared, and I'll get minus 4 on the inside. So again, one of these has to equal 0. So on the one side, this x squared has to equal 0, which means this is 0. And then I have another one here, is 5x squared minus 4th. So I'm going to write another equation for that. 5x squared minus 4 equals 0. Has to equal 0. 5x squared equals 4. I'm adding 4 to the other side. X squared equals 4 fifths, dividing both sides by 5. X equals the square root, I'll just use this little slash line, of 4 fifths. Okay, understand that? And it should be plus or minus the square root of 4 fifths. So I technically have 3 possible relative extrema, right? So remember doing this, I'm going to take my number line. I'll put all these. I'll put 0, positive square root of 4 fifths, and then over here I'll put the negative square root of 4 fifths. And actually this should be a square root over the whole thing. Okay, you can use your calculator if you don't know what this is. Square root of 4 over 5, so 4 fifths is like 0.8. The square root of 0.8, square root of 0.8, let me just pull up a calculator real quick, like so. So in case I don't know what square root of 4 fifths is, oh man, hold on. There you go. Oh, just kidding. Alright. So I don't know what the square root of 4 fifths is. I know 4 fifths is 0.8. So I put 0.8 and I'll take the square root of it. I get 0.89. So this is about 0.89. So what are some good numbers to test? If this is 0.89, the easiest one to test is 1. And on the inside, 0.5. And negative 0.5. And negative 1. Now I'll put these into my original equation up here and see what numbers I get. So I put a negative 1 in here. Okay, so if I put a negative 1 into this problem right here. Oh no. Alright. Negative 1 is x squared, I'm going to get a negative. I put a negative here, I'm going to get 5 minus 4. I'm going to get a positive. So this whole zone is negative. Then I have negative 0.5. This will still stay positive. Oh, hold on. Okay, negative 1 here on the outside would give me a positive. If I put a negative 1 in here, I'll get positive 1. Positive 1 times 5 is 5. 5 is positive. Sorry, so this is positive, positive. This should be positive. Okay, negative 0.5 I put in, I get positive. Put negative 0.5 here, I will get I'll get positive 0.25. 5 times 0.25 will be like 5/4. It's going to be less than 4. This is going to be minus. This whole zone is negative. I'll get the exact same thing if I plug in 0.5 because I have these squareds. And then I'll get the exact same thing if I plug in 1. I'll get positive and positive. And again, if you don't know, you can check on your calculator. You'll get the same thing. So here's my zones. Okay. So that means at negative radical 4/5, since it goes from positive to negative, it goes from increasing to decreasing. I have a max. From negative to negative, that means I have nothing. And then from negative to positive, that means it goes decreasing and then it goes increasing, which means I have a min. Okay. Last one, I need to find points of inflection. So I'll take what I found here and take the derivative one more time. So this 5x to the 4th, or I'll write it here, 5 double prime x is going to be equal to 20x to the 3rd. Oops, 20x to the 3rd. And I will get minus 8x. I will factor, they both have a 4. So I'll take out a 4x, which leaves me with a 5x squared minus 2. One of these has to equal 0. The 4x, when that's equal to 0, when 4x is set to 0, x will equal 0. And then when I plug this in, and when I solve this, sorry, I'm going to get x squared equals 2/5, which means x equals the positive negative square root of 2/5. Okay, and I got to do the same thing for concave up and concave down. Okay, but we're going to run time in this video, so I just want you to get the feel for this. Same thing, here's a problem. Give me, and we did this for the group quiz, give me relative extrema, points of inflection, stuff like that. We didn't get to go over asymptotes, limits of infinity. Maybe we'll go over that when I see y'all on Monday. For now, this video is only about 13 minutes. I want you to take the time right now to do the problem set that I gave you. I put on the little quarter sheet. So answer the problem set questions, and we'll have it due at the end of class. Well, you know what? Hold on to it. Also, the work from today, the work from yesterday, hold on to everything, and we're going to staple it all together. So at the end of class, please finish the problem set, and I'll see you in tomorrow's video. All right, take care.